Thank you, Bob. So I'm going to try to move through quite a bit of data and slides that we have from some of the projects we did this year. So as I mentioned this morning, I feel like our staff was trying to be on top of SWD as much as we could and rolling kind of with the punches of large crops and diversions and putting fruit on the ground. But a lot of the data that I'll show you today were funded projects through Project Green, the Michigan Cherry Committee, and MDAR. So once again, I just want to say thanks to Emily and Karen. We're kind of become quite a team up here in terms of trying to get things done with a pretty minimal crowd. So I'll just give you an overview of what I think, what our traps look like. This is overall trap catch in Northwest Michigan from 2013 to 2016. So average number of SWD caught, and here's like these years. So you can see 2013 looks like it went pretty, like the numbers went pretty high, but it's just because we trapped really far into the season. But I guess the real thing that's really noticeable is this purple line, which is 2016. We're starting to see these average numbers of SWD caught earlier in terms of growing degree days. So here's what that looks like in terms of first catch. We see that similar trend with first catch. So you start to see that rise with 2016 in purple here, but in 2013 our first catch was out here in August, 2014, 2015, and then our first catch is quite a bit earlier in the season in 2016. So what we did in 2016 is we actually had 210 traps in sweet cherries, tart cherries, and wild hosts. We tried to separate those out in our 5 counties so we kind of could give you guys as local look as you could as to what's happening in your neighborhood. So we were hitting the road quite a bit in the 5 counties, and we tried to spread out our research projects over those 5 counties. So this again, these are 2016 data. This is the average number of SWD per trap. And here's where we had our first adult catch. So this year, it was, like I said, much earlier, so June 13th, where we started to catch SWD consistently. Last year and the year before, it was more like June 29th or the 1st of July. The year before was in August, and the year before that was in September. So that's when our first adult catch came about. This is when we first started seeing larvae. So you can see we're catching the first larvae in wild hosts on July 11th. Our first larvae in sweets and tarts was actually right in the middle of sweet cherry harvest, so the 17th of July. Our sweet cherry harvest for most growers started in the back there. And then our tart cherry harvest, again, was about here at the research station. There were some growers that started obviously harvesting earlier, but for us, it started here at the research station around the end of last week of July. And again, you can see that this population is going, is increasing along, and then it's hitting this August 1st, which was almost like a magical date. When we hit that August 1st, that population just took off. So one of the first projects we were interested in, and this goes along with what Dr. Loeb talked about, but what's the influence of some of these wild host or orchard systems on unharvested commercial tart cherry blocks? So we had this hypothesis that we thought that SWD populations were going to build in sweet cherries that were adjacent to tart cherries. And once those guys shook those cherries in sweets, they left some fruit on the tree, they stopped spraying them, the residues dropped off, and we thought that the populations would really ramp up in those sweet cherries and would put pressure on adjacent tart cherries. So what we did is we had 10 sites in 5 counties with 20 traps per site, half in sweet and half in tarts. And then we made a transect, and I'll show you a picture of what that looks like. And then we exchanged these traps and counted the adults for what seemed like forever, but it was really only a few months. And then we sampled for those larvae as fruit ripened. So this is just a pictorial of what that looked like. So we tried to find these orchards, which wasn't as easy as I thought it was going to be. But we tried to have orchards that were less than 50 meters apart. And then we set up these, which are representative of traps. And we would put these traps in tart cherries and then in sweet cherries. So thinking that this border edge, that this sweet cherries, once they moved out of here, they were built up in this or harvested orchard and move into your tart cherries. Okay, so overall, this is what this looks like. So this is the average number of SWD per trap, and these are all the farms together. And you can see this blue line right here is sweet cherries, and these are adult catches right now. And you can see that these populations are increasing as you get out to that August, but you can see that tart cherry is following in that same pattern. So when we break this down into just a couple dates, just to give you guys an idea what this looks like. So this is the influence of harvested sweet cherries on tarts. Again, adult SWDs at trapped catches at June 27th, which would be before sweet cherry harvest, July 17th, which would be kind of at the prime in sweet cherry harvest, and then at August 1st, which would kind of be our tart cherry harvest, give or take, depending on where you're located. So again, the idea, so this is a 0, this is the border between sweets and tarts at the 0 meters right here. The idea that these insects are flying in and moving into tart cherries. All right, I'm missing a couple circles here, but the idea that what I don't see is a really great trend to that. So what I was thinking is that you would have this population building up in sweets and moving to tarts. But actually what we're seeing is that the adult catches per trap are starting in the 100, they're higher in the 100, and again here that we can see it on August 1st, we start to see a little bit of influence from those sweet cherries over into the tart cherries, but again, it's not a trend like I would hope I would see. And then again, you can see that as these numbers increase in sweet cherries, that there may be some influence on these tart cherries, but again, it's not very clear cut. So the influence of harvested sweets on tarts, if we look at the larvae, so then we went back and we started to collect the fruit. So at each one of those sites where we had those traps, we would collect 30 fruit from that tree or adjacent trees around there. So basically these are a total of 300 fruit. And again, sweet cherries, this would be the center of a sweet cherry orchard. Here would be the border between sweets and tarts, and then this would be the center of tart cherries. And so again, these same dates, July 17th would be around sweet cherry harvest, the 25th of July, a week later, and then August 1st. You can see we're catching larvae in these sweet cherries, and they're showing up a little bit at the 0 meters, but they're also showing up at the 100 meters. So there's not a real direct influence of what's coming out of sweet cherries and moving into tart cherries in terms of larvae. So again, they're kind of pretty comparable at the same time we'd be harvesting our tart cherries. So not what we would expect to see. So after I thought that happened, we said, well, do they like sweets? Do they like tarts? What do they really prefer? So this is kind of a quick and dirty study. So it's basically a no choice test between sweets and tarts. So we had some Reginas that were still ripe on the trees, and we had ripening Montmorencys. And we just added those to a container and exposed male and female SWD. And then we sampled the fruit for the larvae. And this was like a little disturbing. We basically had 6 times higher SWD in tart cherries compared to sweet cherries. I'm not saying that they prefer sweets to or tarts to sweets, or is our tart cherries a better host? Those things we don't know. So I think that Larry and I and Emily have talked that we really need to set up some of these choice tests next year to see if there is a discrimination. So I just thought we were going to see a pretty clear-cut line from sweets moving into tarts, and we didn't see that. And I'm just wondering if there's something about tart cherries that they really like. And those are data that we need to still determine. So I think what that sets us up is, this is kind of like the broken record of me last year, is that I still think we have a serious issue where we have to try to control SWD in Montmorency tart cherries. So our initial data suggests that SWD reproduce really well in tart cherries, maybe perhaps better than in sweet cherries, and we need to figure that out. But then we have this exponential SWD growth that's now kind of overlapping with harvest. And so it's particularly problematic with a later tart cherry harvest like we saw this year. So again, if you're leaving those sweets on the trees for longer, will they reproduce faster? And then will we see that influence of sweet cherries on tart cherries the later into the season we go? We have limited excellent insecticides, and we've all talked about this necessity to rotate these chemistries, PHI and retrievement limitations. And then quite frankly, if you ask anyone in this room, it was a time limitation. There's only so much time you can be in the sprayer cab. There's only so much time you can get across that acreage. So there was I think someone from Cornell called it sprayer fatigue or something like that, but it was just the time limitation to actually get through all of your acres. So I think we have a challenge in Montmorency tart cherries. So then we, of course, tried to do some efficacy trials to hopefully show that there are some chemistries out there that are effective. We conducted 8 spray programs up at Northwest, and then Larry conducted some at Trevor Nichols, and we tried to divide those up so we would have good programs and we'd be able to test these programs at 2 different sites. And it's always a good thing to do that because I feel like our data up north, we have such higher pressure with SWD that our data shake out pretty evenly or pretty well. So we evaluated 8 programs here, 2 harvest collections. So we harvested them at 7 days post-treatment, which would be the harvest timing. And then we did a 7 days post-harvest because we wanted to just see what that residue, how long it would stay on those trees, and just see if there was any differences in longevity of programs between these 8 different programs. So we sampled a heck of a lot of fruit, so 64 gallons of fruit for each sample, so 128 gallons of fruit to do this study. And we really like the sugar solution, and Juliana mentioned that this morning. We revised that, and I feel like the sugar solution, Bill Klein doesn't like the sugar solution, but the rest of us do because it keeps the larvae alive. And so you have these larvae that are actually moving where salt will kill them. And so if you're looking at a smashed up internal Montmorency cherry, it looks white and fleshy, which looks like larvae. So the more you can keep them moving, I think the better results that we had, or more convinced we were counting larvae, not internal fruit. So here's our spray programs, just to run through these quickly. So we did a 14-day and a 7-day, and I realized that there's a lot more programs that need to be evaluated, and Larry and I and Emily have talked about this. We just simply need more trees to do this work. We are maxed out at trees this year, so, and I'd like to do this on a bigger scale. So we kind of just chose 14 and 7 days. So we did a warrior at 14, a delegate at 7, a warrior at 14, an imidan at 7, a warrior at 14, an extra at 7, an imidan, a warrior, imidan at 14, warrior at 7, delegate at 14 days, followed up by an extra at 7 days, a Mustang Max at 14, followed by a delegate at 7, and then an imidan at 14 with a Danitol at 7, and then of course the untreated check. So I like this graph. This is exciting that we have something that at least looks pretty good for 1 or single tree reps. So that's one of the things I feel like I see differences when we did work on grower farms. I feel like they could find the holes in, 20 acres of tart cherries, but in a single tree rep, we don't see that as much. But I'm really encouraged by these data because these are the number of larvae in a half gallon of fruit. And you can see we're having tremendous pressure. So that's a lot of larvae in our untreated check. All of these look really good and aren't statistically different except for the imidan 14 days followed by a warrior at 7 days. That's not legal. I just want to put that out there, but we did do it to try that out in the study. So that was statistically the best treatment there. So the other thing that we went back, like I said, this would be 7 days after harvest. So basically it was 14 days between the last spray and this sample. So that's 2 weeks. I realized we would not be recommending a spray to extend your spray intervals to 14 days, and this is really a good example as to why you do that. So we took the untreated check off of the bar graph because it skewed it because there was basically over 300 larvae in a half gallon, an average of a half gallon of fruit. So the pressure is quite tremendous. But you can see that all of these are statistically better than the untreated check. But also, I mean, you're talking like warrior and imidan, 25 larvae and average half gallon of fruit. So there's just no way we're going to get these programs, we're going to be able to stretch intervals. And 14 is out of the question, but it just gives you an example of how quickly that these populations can rise in these settings. And so the other thing that we went back and looked, I thought about it in the middle of the night, and Karen looked this up for you this morning. I was wondering if we had any rain that would have had any wash off between the 7-day sample and the 14, and there was no rain. So this is just strictly loss of residue and not even having to do with rainfall. So Larry gave me these data today, and I think that without going through the huge take-home message, Larry really wants to point out that we have a new material called Harvanta, which is the same active ingredient. It's Exaril, and so Exaril looks excellent as well as this. And so these are Trevor Nichols' results here. So again, their pressure, this is SWD per pound of fruit. I feel like you guys are so lucky down there. But yeah, that's a lot lower than we have up here. And so that's why it's really good to do these trials at a couple different research stations with different levels of pressure. Jim?
It's not the same.
Did you say
Similar?
So it's a different, it's similar, it's not.
Yeah, it's the same mode of action.
Same mode of action,
Who
sorry.
makes it?
And it'll be registered in April.
Who makes it?
It's a Japanese company, owns it right now. And and it looks really good, so.
Yeah, so Larry just wanted me to include that because it does look good, but then what we're hoping, and this is Larry and I are hoping, and I maybe have said this too concretely here, we're hoping that because Harvanta is, similar active ingredient as Extrol, because we hope that'll drop the price of Extrol. That's why Larry wanted us to put that up with that hope. So I think right now we have efficacious insecticide programs for SWD. The optimal program was Imidan 14-day, followed by a Warrior 7-day. Again, this is for research purposes only, because Warrior is a 14-day material. So that's why I asked Larry today, maybe Warrior is the same as Mustang Max, but I do feel like our Mustang Max program broke down in our trials before the Warrior. And whether that's just a fluke of 2016, I'm not sure. But, we talked about a pH label change maybe for something like a Warrior. So these are just something we can go back and look at. And then I guess the other take-home message is just that 14-day post-treatment data demonstrates the importance of keeping those interval tight, or those SWD populations just explode on you. And so all treatments in that had the same number of larvae, and then the Mustang Max 14-day, delegated 7-day provide less control than the other treatments at the 14-day. So the other thing we did is we tried to get to the bottom of this alternate row every day. So I appreciated Brian's comments today that there are some growers and many growers just physically can't get across that acreage. But we wanted to just see if we could compare a 7-day every row to a 7-day alternate row and a 10-day every row versus a 10-day alternate row. We chose Imidan, Baythroid, and Delegate. When we originally wrote the grant, we had 2 other insecticides in there, but frankly, we're out of trees again. So we chose Imidan, Baythroid, and Delegate, and they were all in different classes of insecticides. And we basically sprayed them like you guys would with a air blast sprayer with 60 gallons per acre. And then we came in and we harvested those fruit from the trees at 1 day after spraying, 3 days after spraying, and 7 days. And then again, we brought them into the lab, and then we put male and female flies in there. And then we sampled for larvae. So here's what Imidan looks like. So this is the average number of larvae. And then this is blue is 1-day samples, red is 3-day samples, and then 7-day samples. So 7 days after the application, we went out to see what those treatments look like. So there is pressure, so the untreated check has quite a few larvae in it. Imidan every row looks best. You can start to see just a slight bump if you do an alternate row, Imidan at 7 days. And then you can see that you're starting to see those SWD break through at every row, even at 10 days with Imidan. And then again, alternate row at 10 day, you can see that you're getting closer to 7 larvae in those average larval numbers. Baythroid, these are just data that show, again, there's pressure here. So the every row out of all of these treatments, every row 7 day looks the best. But out at 7 days, you're over at 6 larvae, even with an every row 7-day application of Baythroid. So I think this is a reminder to us that pyrethroids don't last long, particularly in years when it's warm and dry like this year. So again, alternate row 7 days, you can see that between every row 7 days and alternate row 7 days, that Baythroid is far less forgiving than an Imidan would be. And then when you set that out to every row to 10 days to alternate row, there's not a lot of differences there. So and then Delegate, we see some very similar patterns. So every row at 7 days looks the best for Delegate, but you can see alternate row, every other row that by the time you're out at 7 days with Delegate, you could have potentially 15 larvae in that sample. So Delegate does break down pretty quickly. And then every row, 10 days, and an alternate row, 10 days are comparable. So we'll have to run some statistics on this, but I think under high pressure, 7 days, every row with all insecticides is better, than alternate row, just from the data right now. But we'll need to separate that out statistically. Imidam provided the best control in alternate row and every row. So I mean, I think this is no surprise. It seems to be our best material. So if you combine the optimal insecticide and the regime, it's Imidam every row, every 7 days. And then that, you just got to remember, this is under high pressure at our research station with a lot of untreated trees on either side. And then we see under high pressure, we even see efficacy go down when you stretch those intervals to 10 days. I wouldn't recommend alternate row Baythroid or Delegate at this point in the game. SWD larvae were found in all treatments 7 days after the final application. And then even with good sprays, I think our residues may not be adequate after 7 days to prevent SWD infestation after that's really high pressure. So the last, those are kind of the data that I have, and yeah, Bill.
Just to point out that those sprays were started at the end of June too, so
Yeah.
they were,
Yeah,
so
Bill's
it wasn't just a single application out there for those. Those sprays were sequential starting the end of June, so there were, I don't know, 4 or 5 different timings through there.
Yeah, so Bill's point is a good one. So we didn't just come in there and just hit them one time to do an alternate row versus an every row. That was a 4, I think it was a 4 and 5, depending on how it was divided up. So that was like it was a program, an alternate row program versus an every row program.
Is there any prior insecticides?
Yep, so we kept insecticides like a normal insecticide program up until that point. So those are kind of our data that we had, and this is, I guess, a little bit more philosophical in looking again at this wild host issue. So I've been particularly interested in that conversation today, because again, I thought that these SWD populations are going to build in these wild and alternative hosts, and then we're going to move into the commercial blocks and put pressure on your spray programs. And so we did a very similar situation where we had sweets and tarts, but in this case we had wild hosts adjacent to the orchard, and because we couldn't go all the way into a block, we actually just chose wild hosts that were surrounding the orchard. So it was a little bit different than the transects we had ideally wanted to use. And then we used a transect within the tart cherry block at 0 up to 100 meters, and then we sampled for larvae and for adults. So overall, what this looked like is the number of SWD per trap, very similar to what we see in sweets and tarts, but again, these wild hosts really take off right as it kind of coincided with tart cherry harvest, but they do follow a similar pattern. So this is overall, so this is the number of SWD per trap, number of adults. And so again, this is our edge here, our wild hosts, and then this is 0 to the middle of a tart cherry orchard. And these are the different dates where we sampled. So you can see wild hosts are really building at the edge, but again, you see that there's some influence a little bit as you move in. It's got a nice, I think, slope that there might be some evidence that the wild hosts are influencing your orchard edge. But if you look at larvae, we don't see that similar trend. So again, SWD larvae, so these are the number of larvae for all the farms. So I pooled all the data from all these farms where we collected this, and you can see at this July 25th, the numbers of larvae in these hosts, which coincides with black raspberry and raspberry ripening, that these larval numbers are really high. But you don't really see that translating into pressure into a commercial block. So out here, these numbers are fairly similar between the orchard edge and then the middle of the orchard. So then we decided, I thought, oh, that can't be. So Karen pulled all these numbers out and looked at each farm individually. So this is one farm where this is kind of what I expected. So this is the number of larvae per farm, and this indicates that SWD is building in these wild hosts, and then they're moving into the commercial block. So you can see that this influence of wild hosts are moving in, and you're getting a lot of larvae on August 1st in this block. So then when we pulled out these other farms, I don't see a similar trend. So again, this is number of wild hosts, this is farm I, and then you can see the number of larvae and wild hosts is very high. But you can see that they're not coming in and infesting the orchard edge, they're more in the orchard middle. Same thing with orchard farm B here. We have over 600 larvae in these wild hosts, and we have one larva in the middle of the block. And so these are actively managed programs. So these are commercial blocks. So these guys are doing a good job at keeping them out, but for some reason they're showing up in the orchard centers rather than putting that pressure on that orchard end like we had thought. And we see the same thing on farm J. So the number of larvae per farm and wild hosts, and again, the larvae that we're finding in our collections are at the middle of the block rather than the orchard edge. So I had to change the slide. Should we be removing wild hosts? I would say from some of the data suggests that we are putting pressure on our commercial blocks with these populations that are building quickly. So different than in New York, I think that, and I'll show you some data, we have some early ripening hosts that are overlapping with tart cherry ripening, or they even ripened before. So our 2016 results don't support that hypothesis, shows this slam dunk where they're moving from wild hosts into commercial blocks. So, and these are growers with good spray programs. So I think in the future, do we need to, do SWD remain in the orchard during overwintering? Is that how we're getting them in the middle of the block rather than moving in from the orchard edge? Are there cues in addition to color and odors of ripening fruit that SWD use to locate males, places to lay eggs, etc.? Fruit odors, infested trees, we always find that one infested tree that seems to be really hit by SWD with trees on the other side that aren't as infested. So the next thing I'm really interested in, and I know Larry is too, is where they overwinter. And so we started a project in conjunction with the Goot Lab where we placed SWD traps at 6 farms on October 1st. And here's what our data look like so far. And this is only a month's worth of data, but these are the numbers of SWD per trap. This is in the interior of the orchards, and here's on the woods edge. So right now it looks like they're in both places, and whether that will change as it gets colder, as they move out. And so my question to Larry is, are tart cherry orchards really conducive for SWD? Now, they don't need to bother moving in and out of orchards. They have nice sod row centers, they have nice big canopies. So I think that right now, this is only super preliminary, that they're in the orchard and they're moving out. So I'm wondering, is if you have this in-orchard SWD, can they, and they say there, can they get a jump on population growth the following season? Because they're not wasting time farting around, moving in and out of the orchard, they're already there. And again, this idea of this unknown cues attract more flies to particular trees or areas in an orchard. So we had classic examples where we had 7 SWD larvae in 30 fruit from one tree at the center of the orchard, and we had 0 larvae in the other 9 samples throughout the orchard, and we had 0 adult catch. So what are those cues that may be going on at once they hit a tree? Is it a fruit plus infestation? I don't know. And then I was starting to wonder about clump distribution, where you have that pattern in a population where individuals have higher probability to be found in one spot rather than the other. So like the way we're sampling, should we be thinking about that differently if they have this clump distribution? And I think we really need to be thinking about those cues that attract SWD to maybe those centers of the orchard rather than coming in from the edge. And then lastly, do they have this wild host preference? So black raspberry, raspberry, honeysuckle, and mulberry are things that ripen before tart cherries, and these are the ones we find most readily around tart cherry blocks. So our first larvae are detected on the 18th of July in black raspberry and raspberry, and in honeysuckle and mulberry on the 11th of July. But you can see the total number of larvae and larvae per ounce of fruit. They love raspberry and black raspberry. And then to a lesser degree, honeysuckle and mulberry. So overall, I feel like we need more, we're getting more SWD in tarts than sweets. We need to do some choice tests. I think full covers improve control, but I know that may not always be possible. So should we go back and redo those experiments, tightening those intervals? So I think that's something we need to look at. Imidan seems to be the best. And we really think that pyrethroids in a hot, dry year just cannot be extended. And we saw fruit in commercial blocks where we stretched that interval, and Emily will show these data at Orchard Show, where you stretch those intervals, I feel like we get into trouble with pyrethroids. Harvested sweets may not influence tart populations, but I wonder if we just didn't wait long enough. So those later harvesting blocks, you get this population increase in sweets and move into those tarts. And then I don't see really clear trends with our wild hosts yet. And then we just need to look at where SWD overwinter. So I was also really interested in that black plastic work that we saw. So I'm interested in ground covers and manipulating our orchard or our sod row centers and looking at different canopies, different pruning, how we might let more light air in to maybe minimize, humidity or something that makes those orchards super conducive for SWD. Oh, just a second. I just want to say thanks to a few people. So anyways, we had a great summer technicians this year. Marguerite Bull, who's still with us, Aaron Lowers, Lauren Seeloff, and Will Schultz. Jen was really awesome at putting out 1 million fruit nets for us. We had awesome grower cooperators. I think I had to beg more than once not to remove wild hosts so I could do this work. So these guys were really supportive in this, in all of our efforts, our staff. And then, of course, Michigan Cherry Committee, MDAR, Project Green, MSUB, and AgBioResearch has supported all of our research. So that's what I have for today. Questions? Carlos?
Yeah, it's very interesting, your data, and it shows that there is an apparent selection of hosts. The ones that are being reproduced on the wild host remain in the wild host, and the ones that are reproducing in the tart cherry remain in tart cherry, and the ones that reproduce in the sweet cherry basically remain there. So there is this is one particular characteristic of fruit flies that where the parents deposit the eggs, the progeny tends to remain around the same area, and there it shows that the dispersal of those flies is no more than 50 meters. So it might be the case that you select your population from tart cherry and try it in tart cherry, they will be producing very well.
Are you saying the SWD are homebodies? That's really, yeah, that's a good point though. Thank you, Carlos. Jim?
In your data that showed maybe it's overwintering in the orchard.
I don't know that. That's just preliminary.
But I guess at this point, we're not doing a post-harvest. Maybe that's something we need to consider.
Well, so Jim wants to do a post-harvest, or is maybe suggesting maybe we should do a post-harvest spray if they're saying that. I would say we're not ready to do that yet, and I'm just worried because they reproduce so quickly, especially if they're like reproducing in wild hosts and other places, that I don't think we're going to reduce that overall population with a post-harvest spray. So I think in terms of resistance management strategy, I'm not ready to recommend a post-harvest spray yet. Ken, do you have a question?
Yes, the question I have is, what's the difference between an abandoned orchard and a wild host?
So the question is, what's the difference between an abandoned orchard and a wild host? I don't think there's really anything in terms of buildup. And this is just from one example that I've seen where we did have somebody that we're not sure what was sprayed in an orchard, but it was a 40-acre block of infestation. And I could clearly see that those SWD were moving into commercial blocks that were going to be commercially harvested. But it was like, it was not a raspberry plant here or a mulberry here. It was a 40-acre block of infested tart cherries. So I feel like the pressure from that, I don't think you can really stave off those insects moving into those other commercially sprayed blocks.
So it's different if my neighbor's got 2 cherry trees in the front yard.
Yeah, so I think it is different if your neighbor just has a few trees next door. And that's what we see. And I think that's probably, I suggested this to Karen.
If you go on what Carlos was saying, those fruit fly are predisposed to the cherries, and so they'll go into your cherries a lot more readily too.
Yeah, so I don't know that. One of the things I also think we probably should have gone back and done, I think Karen left the room, but I thought I should go back and measure the density of those wild hosts, because I think that we may see differences because that person that had a really huge influence from his wild host into his commercial block had a lot more, when you went out and looked at there was a lot more wild host there than some of the others. So I think density of those wild hosts plays a role, which goes back to your question, Ken. If you have 40 acres next door that is not managed, I think they're much more likely to move into commercial blocks.
It's a numbers game.
Yeah, it's a numbers game, but I thought that we would build up so quickly in the wild hosts and leftover sweet cherries that we weren't gonna be able to battle those numbers. And I don't know if that's a clear-cut case yet. Yes,
On blueberry farms, we have some blueberry farms that are manicured like a golf course. And then we have some that have equipment standing around, weeds growing up, grass growing up, and then that grass dies down, and that's just the perfect place for the SWD. And we catch SWD on those farms much higher, much faster than the well-groomed farms.
thank you. Thanks.
I'm sorry, could you repeat that? I didn't hear all that.
Yeah, so I think,
Maybe not so.
yeah, so, oh, go ahead.
The well-groomed farms, our catches are lower all year versus the farms that have equipment standing around that's been staying there for 5 years, and the weeds are growing up, grass is growing up, and then it dies down, and it's just a perfect nesting area for the SWDs during the winter. And so we're trying to get all our growers just to clean up that old equipment, keep things mowed, keep the driveways mowed, just keep things short.
And I think that we're gonna go back and try to manipulate some of the things in the cherry orchard. And one last thing before I go, we had a lot of treats this year that involved SWD larvae on them, so. I just wanted to say something.